Here is question from NET JRF 2016 from Electrostatics. In this question it is given that for equal charges of plus q each are kept at the vertices of a square of side r. A particle of mass m and charge plus q is placed in the plane of the square at a short distance a, which is less than r from the center. If the motion of the particle is confined to the plane, it will undergo a small oscillation with angular frequency. For options are given. So let this the square whose side is equal to r. So this half distance will be equal to r divided by 2, and this distance will be again r divided by 2. This distance is again r divided by 2. This distance r divided by 2. This distance r divided by 2. This distance, all these distances are r divided by 2, and 4 charges are placed here. So there is a charge plus q, there is a charge plus q, there is a charge plus q is placed here, and there is a charge plus q placed here. Now let this distance is equal to a. Now electric field due to this plus q charge will be in this direction. Let this is E1, and electric field due to this charge will be E2. This is directed in this direction. Now let this makes an angle theta. So let this angle is theta and this angle is theta. If this angle is theta, then these two angles must be equal to theta. So this distance, this small distance will be equal to, if this distance is a and this distance is equal to r divided by 2, so therefore we can write this much distance will be equal to, this much distance will be equal to r divided by 2 plus a, r divided by 2 plus a. Now this E1, there will be two components of E1. One is e cos theta and another one is e sin theta. So this component will be e sin theta, E1 sin theta. This component, there will be another component of E2 which will be equal to E2 sin theta, and there will be one component for E1. That component will be E1 cos theta, and another component for E2, that component will be E2 sin theta, E2 cos theta. So from this diagram we are seeing that E1 equal to E2 because both of the angles are same and charges are same and distance are same. So therefore E1 equal to E2 will be equal to 1 divided by 4 pi epsilon naught into q divided by this much distance. This distance will be equal to r divided by 2 plus a whole square plus r divided by 2 whole square. Now the resultant electric field will be E1 plus, therefore we can say resultant field resultant electric field E1 to y, because these are directed in y direction. So we'll set our coordinate system. This will be our x direction and this direction is our y direction. As their resultant field is directed in y direction, therefore we can say resultant field E1 to y will be equal to 2e, because both e are same in magnitude, 2e cos theta. So from this relation we can see, but cos theta is equal to, if this angle is theta, then we can write cos theta is equal to base divided by hypotenuse. So that will be equal to a plus A plus R divided by 2 divided by A plus R divided by 2 divided by R divided by 2 plus A square plus R divided by 2 square. Therefore our field will be equal to resultant field E 1 to Y will be equal to 1 divided by 4 pi epsilon naught into Q divided by R divided by 2 plus A R divided by 2 plus A square plus R square divided by 4 to the power 3 by 2, and in numerator there will be a term R divided by 2 plus A. Now if this A distance is very small, then we can write this distance will be approximately equal to, therefore we can write E 1 to Y equal to 1 divided by equal to 2 divided by, because 2 is multiplied here, 2 divided by 4 pi epsilon naught into Q divided by R square divided by 2 whole to the power 3 by 2 into R divided by 2 plus A. So from this we can write our resultant field E 1 to Y will be equal to 4 root 2 divided by 4 pi epsilon naught Q divided by R cube multiplied by R divided by 2 plus A. Similarly, if we want to find the electric field due to these two corner charges, this is plus Q, this is again plus Q, there are plus Q, there are again plus Q, and if this distance is equal to A and this total distance is equal to, because this distance is equal to R divided by 2, therefore we can write this length will be equal to R divided by 2 minus A. Now if we divide this into components, this electric field into components, let this is our electric field E3 and this is our electric field E4. So similarly there will be two components of electric field in this direction, and in this direction the components will cancel each other. So therefore we can write E34. Similarly E3 equal to E4, which is equal to 1 divided by 4 pi epsilon naught 1 divided by 4 pi epsilon naught into Q divided by R divided by 2 minus A square plus R square divided by 4. Now the resultant field in this direction will be 2E or E34 in the direction Y will be equal to 2E3 cos phi. Here the angle is confined as phi. This angle is phi. So the value of E34Y will be equal to 2 divided by 4 pi epsilon naught multiplied by Q divided by R divided by 2 minus A square plus R square divided by 4, and again it is multiplied by R divided by 2 minus A. Now from this calculation we can neglect the value of A. So after neglecting we can write the value of E 3 4 comma y will be equal to 4 root 2 q divided by 4 pi epsilon naught divided by 4 pi epsilon naught r cube into r divided by 2 minus a. Now resultant electric field will be, as we are seeing that this net electric field for these two charges is upward directed, and there are two electric, for these two corner charges there are electric field which is directed in this direction. So our net resultant electric field, therefore our resultant electric field E will be equal to 4 root 2 q divided by 4 pi epsilon naught q divided by r cube, and it is multiplied by r divided by 2 minus a minus r divided by 2 plus a. So from this equation we can write our net electric field will be equal to minus 8 root 2 q square divided by 4 pi epsilon naught r cube a. Now this electrostatic force will be, as we know, F equal to Q into E. So therefore the value of our electrostatic force will be minus 8 root 2 q square divided by 4 pi epsilon naught r cube into A. Now again from Newton's law we can write this force will be equal to m into d2a with respect to d t square. So from this equation we can write m into d2a with respect to dt square will be equal to minus 8 root 2 q square divided by 4 pi epsilon naught r cube. So from this equation we can write d2a with respect to dt square will be equal to minus 8 root 2 q square divided by 4 pi epsilon naught m r cube into A. So this equation will become d2a with respect to dt square will be equal to plus 8 root 2 q square divided by 4 pi epsilon naught m r cube into A is equal to 0. Now we will compare, as we know, the well known equation for SHM. SHM is equal to d2a with respect to dt square plus omega square a is equal to 0. This is our equation number 1 and this is our equation number 2. If we compare these two equations, then from this, by comparing these two equations, we will get omega square a will be equal to 8 root 2 q square divided by 4 pi epsilon naught m r square m r cube into A. We can cancel this A from both sides, therefore omega square will be equal to 8 root 2 q square divided by 4 pi epsilon naught m r cube So from this value we can write our value of angular acceleration frequency will be under root, now this 4 and 8 will cancel, 2 root 2 q square divided by pi epsilon naught m r cube. So in our question 4 options are given and it is matching with option number C, therefore our option C is correct. Option, we can write option C is correct.